This week at NASA. Scientists and engineers have worked for years to see the Phoenix Mars lander arrive safely on the Martian surface. Phoenix is scheduled to land on the red planet's northern polar region May 25th. On Mars, Phoenix will do what no other lander has done before: dig into ice-rich soil below the Martian surface.
And it's designed to chip away very quickly at the icy soil. And within about a minute or so, it kicks a fair amount of material into the inside of the scoop, into the chamber.
Phoenix can also claim a number of other firsts, especially in the challenges it faces.
This will be an attempt to be the first successful landing at the polar regions, so that's obviously a challenge. It's going to be the first time we used a propulsive descent system to land on Mars since Viking. We're dealing with a system that's coming into the planet at 12,600 miles an hour, streaming into the planet, and slowing down to basically zero inside 7 minutes. That's always a tough thing to do, no matter how many times you do it, quite frankly.
Phoenix will land on Mars May 25th at approximately 7:30 p.m. Eastern. Commander Mark Kelly and the STS-124 crew are in the final stage of training for their upcoming mission. They'll deliver the Japanese pressurized module and its robotic arm system to the International Space Station.
Well, the Japanese lab is the biggest laboratory. It's actually the biggest module on Space Station. It's pretty heavy. It's 32,000 pounds. It's its own little spacecraft in the sense that it has an environmental system, electrical system, its own computer system, its own robotic arm. It's going to be a world-class laboratory.
Discovery is at Launch Pad 39A at the Kennedy Space Center, ready for a May 31st launch. A joint mission by NASA and the French Space Agency gets underway in June, with the launch of a spacecraft that'll perform a long-term survey of Earth's oceans. The Ocean Surface Topography Mission, or OSTM, will study ocean circulation and the effect oceans have on weather and climate. OSTM should also provide clues on how Earth is responding to global climate change.
Everybody, I think, in the weather community realizes that the farther out you're trying to forecast, the more the ocean provides input to your forecast. If you're trying to forecast climate, you can't do it without the ocean.
The spacecraft will be launched from Vandenberg Air Force Base aboard a United Launch Alliance Delta II rocket on June 15th. The most recent supernova in our Milky Way galaxy has been located, 140 years after it exploded. NASA's Chandra X-ray Observatory and ground-based radio dishes discovered the remnants of the supernova known as G1.9 plus 0.3. When it exploded 140 years ago in the middle of the Milky Way, it couldn't be seen optically because it was obscured by the surrounding dense gas and dust. Today, G1.9 plus 0.3's expanding remnant is detectable in X-ray and radio waves by Chandra and a ground-based array of dishes.
This gives us the first chance to study in detail, because we can observe with Chandra and X-rays and with the VLA and radio the details of how this explosion expands. And this is the first time we've been able to do that for a remnant that is in this age range.
Take a step back.
Dryden Flight Research Center employees recently joined their Air Force peers for 2 days of survival training at Edwards Air Force Base.
Point straight out. Got my flame, just gonna snuff that off. And then there's my smoke.
Led by Air Force Staff Sergeant Brandon Smith, participants practiced skills needed to survive a bailout from a crippled aircraft at sea or over a remote area of land. Training covered safe parachuting into water, parachute water drags, parachute canopy entanglement problems, and how to safely board a life raft. Each participant was taught survival techniques and how to properly use water survival equipment. Under controlled conditions, the flight crews were placed in situations similar to what they might encounter in an actual emergency.
We're standing right beside the Saturn V rocket in Huntsville, Alabama.
Meteorologist Sam Champion hosted a series of live reports from the U.S. Space and Rocket Center in Huntsville for ABC's Good Morning America program. The 2-hour-long network show highlighted the Saturn V rocket as one of the 7 wonders of America.
The scientists that live in this
Designed and built at the Marshall Space Flight Center in Huntsville in the 1960s, NASA's Saturn V powered the Apollo missions to the moon. ABC calls the Saturn V rocket, quote, the embodiment of America's spirit of ingenuity. 25 years ago, NASA launched a new era in spacecraft communications with the first Tracking and Data Relay Satellite, or TDRS. From a geosynchronous orbit 22,300 miles above the equator, it beamed communications from Earth to other orbiting spacecraft and back, establishing itself as a reliable and valuable resource for NASA's space shuttle and other customers. 8 more satellites have since joined the Tracking and Data Relay Satellite System to provide nearly continuous tracking and high bandwidth communications with scores of Earth-orbiting spacecraft and planetary probes. For a quarter of a century, the TDRS network has brought stunning images to Earth from the Hubble Space Telescope, as well as pictures, television, voice, and data from more than 100 space shuttle and International Space Station missions.
I dare to say without communication and capabilities provided by TDRS-like systems, we wouldn't be enjoying much.
A national asset, TDRS is also used by numerous other U.S. government agencies. And that's This Week at NASA.